let's start with those two. The first one, we're finding our x and y intercepts. So I'm going to do one with the full work, and then the second one I'm not going to do as much work. You're going to be putting 0 in for whichever opposite you're solving for. So if I want to put 0 in for x, I would be solving for y. This would just become 0. The 0 I don't really need to worry about, and I would just solve for y. So y equals 3, and I would write that as an ordered pair. I put 0 in for x. So 0, 3 would be my y-intercept. Then I could do the same thing to find x, but I'm going to skip some steps. If I were to put 0 in for y, it would also become 0, so I'm just going to like hold my hand over that, pretend I put 0 in, and just set up my x equation and solve that. So x is -6, and we would write that as an ordered pair. -6, 0. 0 would have been what we put in for x. I'm sorry, for y. So our two intercepts would be -6, 0, and 0, 3. Questions on that? For the second one, it's giving us some function, and it wants us to evaluate when x is -1/3. So every time you see an x, you're going to replace it with -1/3. And whether you put this all in the calculator or do each piece by hand, I'll show you both. So by hand, this would be -1/3 times -1/3, so that would give us 1/9, minus -3/3 would give us -1, minus 2. So we'd have 1/9 minus 3. And then you could either do that part by hand or do it in the calculator. If you did it by hand, you would have to get common denominators. So -26/9 should be our answer there. Let's check in my calculator. So we had -1/3. All of that being squared. Plus 3 times that -1/3 minus 2. That's interesting. Usually it doesn't do that. So -26/9 was that correct answer? Questions on that? And again, doing it by hand was not necessary. That's just if you wanted to. So today we're going to talk about the fourth type of factoring. So just to recall, we talked about GCF, greatest common factor, what you can divide out of everything that they have in common. Grouping, that has 4 terms where you're really using the GCF twice. Difference of squares, where everything is a perfect square and you find the factors that way. Today we're going to be factoring trinomials. So that's 3 terms. So everyone should have these notes in front of them. Yes. Yeah. Did you make the pass already? Do that really fast. There are some rules, one specific rule, and then we'll talk about some others that may help you remember this process a little bit. I like to think about factoring as a puzzle. You may or may not like puzzles. I do. And it's really, you're trying to figure out what goes together with this, what factors go together. So our main rule is you're going to be given something that looks like this, where you're going to have some 1 in front of x squared. You won't see the 1, but it's invisible. It's there. Some number for b, some number for c. Our goal is to find two numbers, or two factors, that multiply to be c, and of those factors, which ones would add up to be b. So we're going to do that and see what happens. So let's start with the first one. So if we are looking for two numbers that multiply to be c and add to b, let's start with the multiplication part. Give me some factors of 12. What times what multiplies to be 12? 6 times 2. I'm going to write these off to the side. 3 times 4. Okay, so we don't have to write it the other way because it would be the same thing. And 1 times 12. So those are all your factors of 12. Colton, make sure you're writing this down. Okay. Of these factors, which ones, if you added them together, would give you 7? So you're going to write your factors like this. It's going to be 2 sets of parentheses. Whatever the variable is going to be your variable first in both. And then whatever sign these have, so if they're positive, you would put plus. If they're negative, you would put minus. So these are both positive, so plus 3, plus 4. If you want to write it the opposite way, x plus 4, x plus 3, that also works. If you want to double check that this is your final answer, you could multiply it back out. So I'm going to do that really quickly. X times x would give us x squared. X times 4 would give us 4x. 3 times x would give us 3x. And then 3 times 4 would give us 12. If we added or combined our like terms, we would get x squared plus 7x plus 12, which is the original, so that works. Do we have any questions on that process? There are some side rules that if it helps you, if you want to use that to remember, bless you, use them. It's not something you have to or need to remember. When you're factoring, if you see a plus and a plus in your equation, in your expression, then your factors are also going to have a plus and a plus. Okay. Let's do another one. Give me factors of 20. Four and what? 2 and what? 5 and 4. And I think that's it. Some of your factors you'll know, some of the numbers will be bigger. Again, if you don't know all your factors, you can start using your calculator, dividing it by 2, by 3, by 4, keep going. 1 will always be a factor, 1 and its will always be a factor. Okay. So if we're looking at these factors, which ones could we add together to get 9? 4 and 5. Mm-hmm. So then our factors would be what? How would we write that? N plus 5. or vice versa. It does not matter. Questions on that? Mm-hmm. Let's do one more of these types and then we'll change. For number 5, what are two numbers that multiply to be 5? 1 and 5. 5 is prime, so the only numbers are 1 and 5. So we're going to be using those. How would we write our factors? These are our numbers. They're both positive. How would we write those final factors? What would it start with? K. And then what would we put? Plus 1 or plus 5, doesn't matter. And then the other one? Or 1. However you wrote it. Okay. The closer that these two numbers are, so this one's 6, this one's 5, that almost guarantees that one of your factors is going to be whatever it says and the other one is going to be 1. Not always, but usually the closer those are, one of your things is going to be 1. Questions so far? Let's do a different type of example. So with 7, disregard that it's negative. What are the factors of 18? 9 and 6 and 3 work. 9 and 2. Are there any others? 18. 4 doesn't work. 5 wouldn't work. Right? When you have something that's negative and your C is negative, that means you have to multiply to get a negative number. The only way you multiply and get a negative number is if one of the things are negative. So you're going to change one of these numbers to be a negative. If you're not sure, you can play around with all of them. So if I had negative 6 plus 3, would that give me a positive 3? No. What about if I switched it and did positive 6 minus 3? No. That one would. So you don't have to keep listing out all your factors if you can immediately think of what the numbers would be. But if it helps you see it, feel free to keep doing that. So then we would write this n plus 6 and n minus 3. So a rule, if you want to remember. So we said if both of them are plus, the two factors will have a plus. For this one, if your C value is negative, the last number is negative, and your B is positive, one of your factors is going to be negative, and the smaller one is going to be that negative. We're trying to do one more. Let's do 10. What are some factors of 54? Start dividing by 2, by 3, by 4, see what you get. And 9. Are there any others? 3. Does 4 work? No. Okay. And then does 7 or 8 work? No. So since these are close, since 7 or 8 don't work, that would be it. We will finish up when we get back from lunch. Okay, so we were working on 10. We found the factors. Now, from these factors, one of them has to be negative. Which one could we make negative that if we added them together would get 3?
What number are we on?
10. And we're trying to figure out which of these factors could we make a negative to add them together to get positive 3. One of them's gonna work. So now make the 6 negative. Okay. So if we make the 6 negative and we add that to 9, that would give us 3. So what would those two factors look like? Whether you do the 6 or the 9 first does not matter. Questions on that one?
Wait, when did we do 6 and 9?
We know those are factors of 54. If we were to make 6 negative, negative 6 plus 9 gives us 3. And none of the others do. Let's do one more of these and then we'll change to a different type. Let's do 14. So what are your factors of 6? 2 and 3. And 1 and 6. Now, if one of these have to be negative, which ones would add together to give us 5? If we made one negative. This is a common mistake, so I'm glad you said that. If I were to make 2 or 3 negative, would it have to be 5? No. 2 and 3 together itself make 5, but one of them must be negative, so that one would not work. This happens often that there are factors that you think would work, but don't really apply. So be careful with those because they're there to throw you off. So either 1 or 6 has to be negative. 1. So how would we write those factors? Questions on those? We're going to do some on the back before we come back to this last section. So turn it over. And then, so we were doing some that had plus plus, some that had plus minus. Now we're going to look for some that have minus plus. Of those, which ones would we like to see, go over, try? 8. will get to 18 here in a minute. Oh, that's, you can do 18. Okay, 8 and 18, if we have others, we'll go over those. So with 8, same thing, still find our factors of 28. What times what gives us 28? 7 and 4. And 2 and 14. Any others? 1 and 28. And I think that's it. Because 5 doesn't work, 6 doesn't work, so that is it. Okay. When you have a minus and a plus, if we're multiplying to get something that's positive, both factors either have to be positive or both have to be negative. So in this case, because b is negative, both of your factors are going to be negative. Sorry, for 8, not 7. I keep pointing to 7. So think about your factors. If they were both negative or both positive, which ones would make 11? Or if they were both negative, make negative 11? Seven and 4, yeah. Sorry, that just like randomly stopped working. So 7 and 4, and if we make them both negative, they would give us this negative 11. So we have x minus 7 and x minus 4. So if you are using the rules that we talked about, plus plus in the expression will give us a plus plus in our factors. Plus minus, one of your factors will be negative, the smaller of the two. Minus plus, they will both be negative. So you can probably guess as to what the last type will be, but we'll get there in a second. Let's do 18 and then any others from that section and then move on to the next. So for 18, I'm thinking this one is a weird one. It's because the variables are weird. So still look at the last one, but just look at the number. What are your factors of 7? One and 7 is prime. So remember, if these two are close, one and whatever the number is given is probably going to be your factors. They both have to be negative. Because this has two sets of variables, it's going to be m and then n. I'm trying to make sure I'm doing this right first. M minus 1n and m minus 7n. So because of the two variables, you have to have them both, but they wouldn't be together. I am going to multiply this back out just to make sure I wrote that correctly. M times m would give us m squared. M times negative 7n would be negative 7mn. Negative n times m would be negative nm, or mn, doesn't matter. And then negative n, times negative 7n would be a positive 7n squared. So that does work. So if you got something that had multiple variables, you would just split them up put the numbers with the second one as we've been doing with our factors, putting it second, it would just also have the second variable. Questions on that one? I know that one's a little bit different. And then before we do the last type, if you have any other questions you want to see, go over 7, 10, 14, or 12. We haven't talked about that type yet, so hold on. Alright, so let's go back to the front, and then if we want to still do 9 after that, we can do that. Alright, on the last 4, 15 through 18, those are all minus minus. So think about the things we've talked about. Plus plus will give us plus plus, minus. Nope, I said the numbers. Plus, minus, 1 will be negative, the smaller of the two. Minus, plus, they'll both be negative. If these are both negative, whatever is missing from that is going to be what we're doing here. Of these 4, which one do we want to see first? 18. Okay. So for 18, let's find factors of 72. And actually, I'm not going to write the factors this time because I want you to get in the habit of finding the factors. So you find the factors of 72.
9 and 8?
Sure, I'm not writing them down. And then think about, of all the factors of 72, which one could we make negative so that when we add them together we get negative 14? Go through your factors, make one negative, and then add those numbers together, see which one will give you negative 14. I think they have those two factors. Something
4 and 18.
4 and 18. Which one would be negative?
3 and 24.
So I'm not going to write them all. Would 4 and 18 work for this?
Which one is
Would 4 and 18 work for this? If we make one of them negative, which one would be negative? So we do x, not k. X minus 18 and x plus 4, those would be our answers. So as I mentioned earlier, if you know your factors, you don't have to make that factor tree or list them out. But if that helps you see them to eliminate, you can definitely keep doing that. So the rule on this one, if you're remembering the rules, is if you have minus minus, one of your factors are going to be negative, and the bigger number is going to be the negative. Do we have questions on that one? Pick another one from that section. That we want to see, go over, have questions about. Okay. So So for 16, think of the factors of 3. One and 3. There's only 2 factors. One of them has to be negative. Which one would be negative? The 3. So then our 2-factor answers would be A minus 3 and A plus 3. Sid, did you still want to see 9 on the back? Okay. And then any others we want to see on this page or on the back? On this page or on the back? Disregard 19 through 24 because we're going to go back to that here in a minute. Okay, so we have 9, we have 17. Any others we want to see, go over, have questions about? On this page? Yeah. Alright, so let's start with 9. Factors of 90. There's a lot. 10 and 9 would work. Something else to kind of think about, if this is 1, your 2 factors are going to be 1 apart from each other. So like 10 and 9. If these are both minus, one of them have to be negative. Which one would be negative? Say that one more time. I said 10 and 9 would work for this. One of them have to be negative because this is negative. Which one would be negative? 10. Because if they add together, they got to be negative 1. So what would those 2 factors be? We have negative 10 and positive 9. Minus 10 and n plus 9. Correct. Okay, so there's a lot of stuff that happened there that we didn't write down, but those are all things that you can write down. The factors, putting one, making one negative, seeing if they add together to be negative 1, all of those things. For 14, factors of 56. I'll list these out because there are a lot. Two and what? 28. As you're listing out factors, you could start eliminating, like if I made them both negative, would I get negative 15? Not with the first one, not with the second one. What about if we divide by 3? Or 4. Would 4 and 14 work to give us 15? No. So that wouldn't work. Keep going. 5 wouldn't work. What about 6? And then is 56 divisible by 6? No. Okay. And then 7? 7. If I were to add those together, would we get 15?
Yep.
Yes. We just have to make them both negative. So what would those factors be? Not plus?
Minus 7, sorry. Minus 7 and b plus.
Minus both have to be negative. Questions on that one? Okay. For 17, this is like 18, where we have the two different the two different variables. So we're going to have an x and a y in our factors. Does 51 have... That's not the question I was trying to ask. What are the factors of 51? We could actually stop there, because if one of these are negative, they're going to give us negative 14. Which one? If 17 is negative. So you would need x first and then y. A positive 3 with your y. And a negative 17 with your y. If you wanted to multiply it back out to double check, you should get the same answer. I'm not going to do that for the sake of time. Okay. Questions on that one? Then there is one last thing we need to talk about with trinomials. That sometimes you'll get trinomials where your a is not 1. But it can be factored out by GCF. Sometimes that's also not the case, and we'll talk about that other case next time. But let's start with 19. Sometimes you'll have a GCF that we can factor out first so that it takes us back to what we've been doing. Does this have a GCF? And if so, what is it? What do those have in common, if anything? Mm-hmm. 2. Yep. So we're going to divide everything by 2. What would be left? Negative 4k. And then minus 45, yes. Then you would just focus on the inside and do the same thing we've been doing. Find factors of 45. And of those two factors, because this is negative, one of them have to be negative. So find factors of 45, make one of them negative, and see which ones would add together to give you negative 4. Doesn't have a whole lot of factors, so think about what could go into 45. 5 and 9. If we were to make one of them negative, would we get negative 4? If we added them together? Which one? 9. 9. There you go. So if we make the 9 negative and add it to 5, we would get negative 4. So then we would write those two factors, k plus 5, k minus 9, and bring down the 2 that you factored out because it's still part of the answer. To check yourself, you can multiply in a couple different ways. Either distribute the 2 here and then multiply that over. Multiply your 2 sets of parentheses first, and then multiply it by 2. You can do it out of order, multiply the 2 to the k minus 9, and then multiply that out. How you do that doesn't matter. The only thing that would change your answer is if you forget to bring down your GCF and then try to multiply it. You will not get the same answer. So be careful with that. Right. Questions on that? Yes. Did you make a pass already? Go ahead and do that. For the number 20, what do those have in common? Do all of them have x squared? Do all of them have numbers? Including this first one? So x. We divided them all by x. What would be left? I didn't mean to do that. Hold on. I lost my mouse. There it is. Aaron, say that one more time. I heard x squared and then. Then you're thinking about factors of 48. Okay. If I had 12 and 4 and one of them needs to be negative, if I added them together, would that give you 2? No. So not 12 and 4. Did it show up? Okay. 6 and 8. If we made one of those negative and added them together, would we get 2? Yes. Which one would we make negative? Did it show up for her? Because I can see hers too. Which one is negative? Sorry. With 6 and 8, one of them could be negative. So x minus 6, x plus 8. If you do find factors and you're thinking, I can't make one of them negative and get this answer, you may have chosen the wrong factors. So just be mindful of that. Right. And then this last one. Does it have a GCF for 21? Is there something those three numbers have in common? 4. So if we divide 4 out of each of these, what's left? Really close. Think about your factors of 30. If you need to make one of them negative, which ones would add to be 13? Negative 13. What are some factors of 30? If I made one of those negative, would they get negative 13? one is negative. If they were both negative, then yes. So this one's a good one that will trip people up. The most common mistake, because 3 and 10, make 30 when you multiply it, and 3 plus 10 will give you 13. If this is negative, one of those things has to be negative. So be careful with that. So not 10 and 3, I almost said 13 and 3. But something else. 2 and 15. Which one would be negative? Do we have any others in that section we want to see, go over, have questions about? I will say that for these examples where it's a trinomial where a is supposed to be 1, but it's not, whatever the number is in front of x squared, m squared, whatever the variable is, that's usually going to be your GCF. But if there's not a number, there might just be another variable. So does 24 have a GCF, and if so, what is it? For 24. We're just looking for... Got it. We're just looking for what do those three have in common. Five. If we divided each of those by 5, what would be left? M squared plus 6 m minus 7. What are your factors of 7? Okay. So those are the only factors of prime. Which of those would be negative to make this 6? 1. So then 5 times m minus 1 and m plus 7. So, you guys have a little over 30 minutes to easily get all of your Khan Academy done. The one that's due next Friday, the 2 that are due Friday, the one from last week if you haven't done those. So there really isn't any reason you shouldn't be able to get those done in class today. Then if you need more practice, you do have your notes and the rest of those examples, so you can use that as additional practice. Let us know if you have questions. Use this time wisely. If you finish the Khan Academy and need to finish your test or do retake work, then you can work on that.